Hello guys, welcome back to my channel Algorithm Minds. My name is Asan Khurram, and in this channel I teach programming skills in Python, MATLAB and R programming. I also teach theoretical concept as well as practical programming skills in data science. So I request you to subscribe to my channel, hit the notification bell icon button. So in today's tutorial video, which will be a second video in the series of MATLAB foundational programming skills. So in this video, I'm going to teach you about MATLAB matrix and array operations. Basically, we will do some arithmetic operations on matrix in MATLAB and some equation solution as well. So let's move on and actually discuss today's lecture, and I'm going to teach you step by step. So stay tuned with me. So following are the content of this video. We will start with systems of linear equation, power, exponential, eigenvalues, and basic matrix operations. Okay, so as I have told you earlier that MATLAB has pre-built functions that help us allow to perform specific operations. The operation could be a matrix generation. In that case, we have like a set of MATLAB functions that generate matrix. So we have I, we have zeros, we have ones, we have diagonal, then we have rand and randi. Zeros and ones we have already discussed in the previous video, and also the diagonal. And the I actually returns a m by n matrix with 1 on the main diagonal item. Then we have rand, which returns an n by m matrix of random number. And then we have rand I, which takes 3 input arguments. The first is actually the number, then the two ones are actually the order of the matrix. Returns an m by m matrix of random numbers from 1 to the specific number that you have actually defined. So we are going to exercise those concepts and these things in MATLAB environment. Let's move on and actually discuss about this randi. Okay, so randi will actually generate random integers from 1 to the value you have defined as the first input argument. In that case, it is 5. Then also define the order of matrix. So the resultant order of matrix will be defined by rows and columns. So it takes 3 input arguments. First one is the maximum number that you want to generate the random matrix, the element that the elements of matrix that has the maximum number, and then the order of matrix. Okay, so that's how you use randi function in MATLAB. Let me just copy this code, and now you can see that we have generated a matrix that has an order of 3 rows, 3 columns, where the maximum values is 5. So the values will range from 1 to 5. Now we can change this statement here. Let me say we want to change this value to 10. So now it will generate a matrix of 3 rows and 3 columns that has an element values that are randomly generated between 1 to 10. So that's how randi actually works in MATLAB. So we have another function I. If you recall that I actually will create a matrix, a diagonal matrix, where the values of the diagonal element will be 1. So simply it generates the square matrix of nth row and nth column. So in our case, we put 3. So it will generate a matrix that has 3 rows, 3 columns, and the diagonal elements are actually having a value of 1. Okay. So now you understand the concept of matrix generators in MATLAB. And the following is the list of matrix generators in MATLAB, which can use to generate matrices in MATLAB. Besides defining your own matrix, if you want to define your own matrix, so if you recall that we are going to assign a variable name, let's say A, and we will use square brackets to define the matrix. And we will define the row elements by writing the elements and then putting space in between the elements, 3, 4. And now if you want to define a column, you have to put semicolon. So if you want to define an other row, second row, you have to put colon. So I have put colon. Now I will be going to define the row elements of the second row. So I will just put 4, 6, and 7. So that's how you define your own matrix in MATLAB. That being said, let's move on to matrix operations. So obviously there are some basics matrix operations, like we can add two matrices. So in our case, in this case, I'm actually adding A and B. So let me just change the order of A to 3 rows and 3 columns. Now in order we can perform matrix operations in MATLAB. I will say assign a variable name X, then I will equate its value. Let's say A plus B. Okay, so I'm adding the elements of A and elements of B. So basically it's a matrix addition problem. So here now you see that we can perform array operations in MATLAB. How we can perform array operations in MATLAB? In the same way, we can subtract values from two matrices by using simple negative sign here. Okay, so now you can see that the values have been subtracted. In the same way, you can actually do the multiplication. So we have done addition, we have done subtraction. In the same way, we can perform matrix operation of multiplication. For this purpose, I have to define two vectors here, U and V. So now you can see that U has 3 rows and 1 column, and V has 1 row and 3 columns. So we are going to now do the multiplication of U steric V. So that will perform the multiplication of matrices. And we can also change the order by we can like we can put V first and U second. This typo mistake here. So now you can see the multiplication has been done and the order has been changed. In the same way, you can actually calculate the inverse of matrix. For example, we have A, matrix A. Now, if you want to calculate the inverse of matrix, let's say I will rename it A underscore I and V. Then I will put equal to sign. And in order to calculate the inverse, I am going to use MATLAB function I and V. Then pass A as input argument. This way, it will calculate the inverse of A. In the same way, I can calculate the determinant of A. It's quite easy to do. Just write any variable name. Let's say we write it D, then is equal to DET. This is the MATLAB function to calculate the determinant. I am passing A as an input argument to this function. Now, in this way, we calculated the determinant of A. Now, let's move on and understand the concept of how you can actually solve an equation in MATLAB. Okay, so these are some array operations in matrix. We can perform addition, we can perform subtraction, we can perform multiplications, we can perform the multiplication of the matrix, and in order to do the multiplication element wise, we have to use dot. Okay, and in the same way, we can perform exponential. We can do exponential. We can also do division as well. Okay, and let's move on and discuss about how we can solve system of linear equations in MATLAB. For example, we have a system of linear equation in the form of AX is equal to B. In matrix notation, the general problem takes the following form. Given two matrices A and B, does there exist a unique matrix X so that AX is equal to B? So in the solution in our case will be X is equal to B divided by A, which generates the solution to the matrix equation AX is equal to B. So now, for example, we have a system of equation where the coefficient of equation is represented by A matrix, and the resultant value, that B value, is generated by U in the order of 3 rows and 1 column. The solution of this system of equation will be equal to X is equal to A divided by U. So that is exactly what we have done here. So first of all, we will define our coefficient of equations. We have this A. Then we will define B or U in this case. And finally, we are going to find the values, a unique solution that will satisfy the equation AX is equal to B. Now, this is the solution we get out of it. Okay. Finally, there are some functions to calculate the inverse of a. For example, if a is not singular, then that case, we can also use P inverse function of MATLAB to calculate the inverse of matrix A. And in the same way, you can the multiplication of a comma a can be done by using exponential power a power 2, and we can also power a matrix by using inverse of a. So we will see that inverse of a and a exponential minus power 1 are equal. That's why it's representing a logical 1 in it. Finally, we can actually calculate the eigenvalues of a matrix A. For example, we have a matrix A and we want to actually calculate its eigenvalues. Its eigenvalues will be stored in D matrix here. So that's how you can actually calculate eigenvalues in MATLAB. That's it for now. I hope this tutorial have been helpful. If you have any questions regarding today's lecture or previous lectures, feel free to write down comments. I will be happy to help you out. That's it for now. In the upcoming video, I will discuss about equation solution in MATLAB. Thank you for joining me, and I will catch you soon in the next video.